Hello. What you're about to see is more of a show and tell than a presentation. It's images of the past week, not necessarily related to what I'm going to read in this script. It's good to have you all here. Thank you for joining us here on tiny Ebadon Island in the far northwest corner of Kwajalein Atoll. I want to start by noting that all of the images you'll see over the next few minutes were taken by Lorenzo Mosha. I recommend you admire more of his work on his website, lorenzomosha.com. The team here on Ebadon is from Seattle, San Diego, Honolulu, Tampa, and Rome, Italy. We're here working on a 2023 capstone project we'll describe shortly, and that project is a part of the Kwajalein Atoll Sustainability Laboratory that appeared as a Marshallese NGO over the past year here in the Marshall Islands. That lab that we called KASL has been formed to give the Marshallese a place to gather ideas that might help them and many others adapt to climate change. Several people around me right now, Marshallese and non-Marshallese, are a part of KASL. This was our first year of discovery, and we spent it learning just how many good ideas there are in the world around climate adaptation, and how many of them benefit from a population that has a strong, science-based educational foundation. That last part was not really a surprise, but it did shape what we've done in unexpected ways. The agenda for this presentation is fairly long, but we'll move through it briskly. You're going to hear some introductions, a bit about our first-year anchor research project called a Climate Security Research Station, the environmental sensors we're installing, the communications gear that will broadcast data from those sensors around the world for the coming 9 months, the offline educational capability that's also broadcasting from this Jabake nest to the only school on Ebadon Island, the possibilities for another version of this building to transition from land-based to water-based as early as next year, our plans for sharing everything we've learned this year in Honolulu next June, the educational curriculum we're testing now this month, and how we hope to create climate navigators within the young people of the Marshall Islands who will work with us on climate adaptation research for the next 10 years or so. At about that mark, roughly 2035, it's very possible this section of the Marshall Islands will become uninhabitable. But if we do our job, Marshallese kids will have a bit more in tools, techniques, and experience in climate adaptation than almost anyone in their adopted countries. They'll arrive in their new homes as valuable experts rather than as despondent refugees. My name is Eric Rasmussen. I'm a physician and a principal scientist within the U.S. Office of Naval Research. KASL is physically located on Ebeye Island within Kwajalein Atoll in the Marshall Islands, an independent nation freely associated with the United States. I'm the research director for KASL. Above me in the org chart is the managing director, an American, and above him is the Marshallese executive director. Associated with me is the research venue coordinator on Kwajalein Atoll, who is also a Marshallese. This is a climate-focused research effort deeply integrated between Americans and our indigenous Marshallese partners. KASL was formed to meet Marshallese needs in research around climate adaptation. That involves a global, low-elevation coastal zone model of risk and need. In mapping out the risk requirements with the Marshallese and with global experts elsewhere, we found 12 sectors, starting with cultural preservation, information transfer, and education. Let's introduce the team. Marshallese Senator Kitlang Kabua is the founder of the KASL idea. Senator Kabua is also the Minister of Culture and Internal Affairs, and we're grateful for her association. Greg Nakano is the Managing Director of KASL, and I work for him. Dan Kenny is our lead engineer. Dr. Rebecca Goolsby is our program manager at the U.S. Office of Naval Research, and we're deeply grateful for her support. Scott Paul is the city manager for Kwajalein Atoll and our research venue coordinator for Kwajalein Atoll. Abon Erlong, who solved 100 problems over the past week, has been indispensable. Lorenzo Mosha from Rome is our documentarian. Peter Cloutier is from USAID, and he's currently faculty at Joint Special Operations University in Tampa, Florida. Jelton Anjane is the Deputy Commissioner of Education for Kwajalein Atoll and has helped absolutely everything happen. We're also grateful to Alex Hatoum of IHS, Gay Matthews of the Applied Hope Foundation, Veronica Kenny as our STEM curriculum developer, Senator David Paul of the Njetla, the Marshallese Parliament, and of course, Iraj Laplap Michael Kabua of the Kwajalein Peoples. We were able to be efficient this week and made to feel very welcome because of the generosity of Senator David Paul working with Mayor Hirata Kabua and his CalGov staff. They took it upon themselves to ensure their visitors to a remote island were comfortable by any measure, and they were successful far beyond our expectations. We also want to offer a special thanks to the Marshallese of Ebadon Island, including Kibut, Joel, and David, but especially indigenous Iraj Laplap Michael Kabua for the temporary use of his land. We could not have had this year without his support. And thanks to Irene Paul, who supported our KASL effort energetically on this island where she was ELAP, the indigenous island leader, but whom we lost this spring. This research station has been named in her honor. As you can tell, this broadcast is the culmination of much work by many people, close and far, and we are grateful to all of you. For overall research context, there are roughly a dozen tasks wrapped into this month on this island, and we'll spend some time describing the primary effort first, the one that makes all the others possible, then briefly describe the others that surround it. Let's start with disruptions. We've chosen to work on climate adaptation in very challenging places so that no one can argue that their place is harder than our place. Ebadon is very far from where most of us live, and getting here is difficult. We arranged for a 14-day research, assembly, and teaching effort with a team of 7 people. We came in from around the world to Honolulu because there are only 3 flights a week from the United States to this nation. Then United Airlines melted down on the 4th of July weekend. Thousands of flights were canceled, including ours, and we could not get another flight to Kwajalein for 7 days. But we have hard stops for members of the team, so we could not simply shift a week forward. We had to reduce our ambitions. So, 6 months of planning, a 14-day research expedition, had to become a 7-day effort. I cannot express anywhere near adequate gratitude for the remarkable recovery we achieved. That recovery was designed by Dan Kenny and powered by many people, including our outstanding Coast Guard Academy cadets, Hannah and Sadie. Let's talk about what they did, starting with the Anchor Project. As we mentioned, the Marshallese priorities in climate adaptation were cultural preservation, information flow, and education. There are new ways being developed to do each of those, so we started by designing a building for KASL that draws from modern materials science and very ancient Marshallese culture. The Jabake nest, sitting a few hundred yards from me, is a robust shelter assembled over the past 6 days by a small team of newly trained people with no special skills, many of whom were Ebadon villagers. The nest we built is strong, safe, simple, and cheap. We put it together from bare ground with a few young men from here on Ebadon in a week. Total cost of materials is less than $9,000 US, and it will last 30 years. There are assembly diagrams, assembly videos, and a bill of materials. Jabake, incidentally, is the Marshallese name for the rare hawksbill turtle. In Marshallese mythology, Jabake was a turtle goddess who rescued her granddaughter from an abusive relationship and spirited her away to an island that provided everything. We found that the association with climate impact and adaptation fit well. We built the nest to look like an indigenous Marshallese home as depicted in illustrations done by naval explorers in the 1800s. We used sheets of expanded polystyrene foam, EPS, that we cut by hand with a hot wire. Then we applied a thin cement skin that was also mixed and applied by hand. Let's take a moment to talk about EPS. One version of that polystyrene is styrofoam. Our entire team is deeply opposed to single-use plastics and to the use of fossil fuels for anything if we can avoid it. But the material we're using for this building is very different from styrofoam. It's made from 80% recycled plastics and is intended to last for decades. We consider it to be the very best of the available materials for the construction of climate-adaptive shelters, and we're happy to provide much more information about our building material choices for anyone who's curious. In fastening the EPS together, we used an insulating adhesive rather than nails, so the nest is seamless, strong, lightweight, and easy to assemble by hand using simple tools and a ladder. The result is a building process that left less than 2% waste, by far the most efficient modern construction process of any we researched. The building, with materials donated by the Applied Hope Foundation and transportation donated by Matson Shipping Lines, is simple and designed to do three things very well. Number one, collect data from environmental sensors in the lagoon, the ocean, the soil, the freshwater aquifer, the atmosphere, and about the weather. Then transmit it all to the cloud day in and day out, unattended for months. Number two, deliver offline educational resources to local schools that include the entire Wikipedia, most of the Khan Academy videos, and a half a dozen other teaching libraries for science and climate. They're available through a browser on any phone or laptop near the school through a local Wi-Fi cloud that does not require the internet. It is in the nest and all in a digital package smaller than my hand. And three, this nest is to provide a very robust physical community shelter in a disaster. It's built using 6-foot ground screws, and the floor is 42 inches above the ground. The EPS and cement skin are extremely strong because we use a formula that's rated for Category 5 storms and earthquakes of magnitude 8.7. While the building is not designed as a habitation, it can keep people safe in an emergency. The building itself is a Marshallese design, 12 feet wide, 24 feet long, with a high peak and a side porch. It has 2 rooms, a scientific workroom in the front with a table, chairs, data collection equipment, and communications gear, and the back room can sleep 4. But, we stress again, this station is not intended to be housing. There is no water, sanitation, cooking, showers, or beds. This space is for the science, not the scientists, but it can serve as a very strong basic shelter when needed. We've incorporated a side platform specifically for rain-fed vertical farming as taught at the Barefoot College in Mumbai, India. We'll have 8 of their 10-foot vertical towers generating mixed vegetable calories every month of the year. Protein, of course, is provided by the sea. This Ebeye nest is designed to be coated in a third layer of a locally made limestone cement wash derived from old seashells and manufactured over a coconut husk fire on our beach 3 days ago. It's rolled on by hand using common deck brushes and is extremely strong, very lightweight, resistant to rot, mold, insects, salt, wind, ocean overwash, heat, or cold, and the result is a smooth, bright white finish that looks like the hillside villages on the Adriatic coast of Croatia. Once a few coats have dried, the surface can be painted in any colors or patterns you like. It's expected to last 30 years or more with an external recoating every few years, and that's longer than the Marshall Islands are expected to be habitable. It's kind of fun to recognize that here on Ebadon, there are lime burners who create lime from seashells to create the slaked lime required for betel nut, a mild stimulant. They had no idea you could make a cement from the same process, but they did it on the beach with us. They, in turn, taught us how to build a lime extraction fire using coconut waste. One unusual part of this design is that everything I've just described can be unbolted from the ground screws, then have one extra floor layer installed and one pontoon attached on the non-platform side, and this shelter can then be moved over rollers onto the water. It will float indefinitely, anchored in the lagoon and serving as a shelter, as a fish aggregator from the shade it provides, and as a mariculture farm. We'd intended to demonstrate this transition to a floating station with this shelter, but the Marshallese have asked us that we leave this one alone. We're building adjacent to the only school on Ebadon, and we're throwing a useful Wi-Fi cloud that the students need. And so we've agreed. Let me stress that the Marshallese of Ebadon chose to be deep and integral partners with us on the Ebeye site. They started by providing unending, cold, clean drinking water. Then they started asking questions, and then helping, and then solving with us the many challenges we ran into, and by last night, they had completely taken over finishing this very unusual construction process just to show they could, and it looks great. Sensors. In the front science room of the nest, we have a Kiwi server for the educational materials, a Sumi server for data storage, and a Starlink satellite terminal. We're designed to receive data over a LoRa radio network broadcasting from extensive environmental sensors being collected in this room up to cloud storage and then to backup on another Sumi server in San Diego. Those designed environmental sensors include citizen science biodiversity data collection using Android applications that include an educational curriculum for plants, animals, insects, reef inhabitants, and crop yields, including coconut and taro. Number 2, coral reef monitoring from underwater cameras and drones. Number 3, ocean temperature at 1 meter and 3 meter depth with pH. Number 4, air quality using P1, P2.5, and 10 micron particulates. Number 5, a professional-grade weather station with temperature, barometric pressure, wind direction and velocity, rainfall, dew point, heat index, and solar irradiation, all uploaded as Ebadon to Weather Underground for global accessibility. Number 6, beach erosion images to be done quarterly. Number 7, mangrove and pandanus mapping and conservation, also to be done quarterly. Number 8, Google Street View documentation for this island, Ebadon, and for Ebeye Island down at the southeastern corner of Kwajalein Atoll. Sadie and Hannah, our Coast Guard cadets, started that Street View collection with the kids here on Ebadon this week. If you look up Ebadon on Google Maps, then bring out the little yellow man, you'll see their start. We started Street View documentation on Ebeye, another Kwajalein island, in 2019 with a detailed focus on their reef. We'll expand that next week, and by the time you're listening to this, you can go out to Ebeye Island on Google Maps and see their Street View work there. Number 9, traditional environmental knowledge, capture, and documentation. We had conversations this week with elders on this island about the changes they are seeing and where we should study. We recorded those conversations. Now, some of the sensors I just described are already in place and working. Some will appear over the next few months as our partners come back in August for some installations, and some will be a Marshallese choice whenever they make it. Now, I mentioned complementary experiments to this anchor effort. Since we have this Ebeye nest shelter, we wondered what we could do with it with very little budget, but lots of need. We came up with a few things that I'm just going to rattle off, and then we'll move to questions. Number 1, biorock. We decided we could grow biorock through an electrified artificial reef using floating solar panels for power, and you can look up the term biorock on Wikipedia. We could then anchor an underwater camera to document the develop of expanded coral reefs in Kwajalein Lagoon for the Marshallese using electrified scrap metal from their landfill. That idea came from combining the Mars Corporation efforts in Indonesia with Line Bay's research in Cairns, Australia for the Great Barrier Reef. That artificial reef construction using biorock had to be sacrificed last week after the United Airlines debacle, but we'll get to it. The underwater reef camera images will be uploaded daily through our Starlink terminal. Number 2, cement. Dan Kenny came up with 2 cement manufacturing processes using local materials, allowing bio-derived cement to be made using low-temperature calcium carbonate, so seashells, for one process, and desalination brine waste for another process. The seashell cement we've all... I think that's an old joke. The seashell cement we have already manufactured over a coconut bio-waste fire on the beach, and I have a sample. The idea worked. But the desal brine requires more chemistry than we can do ad hoc on a remote Pacific island. We'll be collecting desalination brine from the small desalinator on Ebeye later this week and doing the required chemistry at the Chemistry Department laboratories of the University of Washington through the kind support of Dr. Lori Robbins. We'll know more later if the industrial manufacturing process looks feasible. If so, it's a low-intensity cement manufacturing from another high-volume problematic waste product, and we think that's an interesting win. Number 3, citizen science. We are working with an old friend of mine, Dr. Muki Hakle, at University College London, on his Extreme Citizen Science program in partnership with Living Planet Laboratories in Paris. His guidebooks, Muki's, are shaping our teaching within Spartan Camp, the STEM summer school now underway with us here on Ebadon and Majato Islands, and our data collection processes. Veronica Kenny has developed a water-based STEM curriculum, both salt and fresh, with the permission and support of Jelton Anjane, the Deputy Education Commissioner, and we're already getting started on the education of young climate navigators. These students will do some of the data collection from our environmental sensors. Number 4, climate curriculum development. Since we have Veronica and Jelton as active teachers, and the STEM summer school was a reason to explore climate teaching, we're developing a climate curriculum, grades 8 through 12, with hands-on citizen science of increasing sophistication. It does not currently exist in the Marshall Islands, and it's of interest to both the Marshallese and the Assistant Secretary of the Army for implementation of the Biden administration climate strategy, published in 2021, and within the Indo-Pacific strategy, published in 2022. We'll be working with Paul Haddock of PREL to ensure anything that seems useful can be translated into Marshallese and incorporated into PREL's curriculum planning for the Marshallese. Number 5, LiDAR and bathymetry release. We are very big fans of Dr. Kurt Storlazzi at U.S. Geological Survey and his work on ocean-based threats to Pacific atoll nations. He was a distant part of a recent survey of Kwajalein Atoll's islands and lagoon, and we're working with him to ensure the Marshallese get a copy of that LiDAR and bathymetry data. Number 6, Joint Special Operations University exercises and demonstrations. One of our close colleagues working here in the room with us is Joint Special Operations faculty member Peter Cloutier from USAID. Peter is reviewing the possibility of refocusing some special operations exercises onto Pacific atoll nations that need the indigenous physical and social support that was the original purpose of special operators during the Vietnam War. He's also working with the Marshallese National Disaster Management Office to assess response coordination as climate change makes storms more frequent, more intense, and of longer duration. TOTKAS. Number 7 is TOTKAS, the ocean that connects us. The Ocean That Connects Us is a New Zealand initiative by Jeff Wood at Rosmini College in Auckland, New Zealand. The effort is an after-school extracurricular activity focused on climate change for high schools around the Pacific Rim. There are schools involved from Punta Arenas in Chile to Mombasa in Kenya, and it's very popular. KASL has already helped 2 schools on Ebeye to become a part of the TOTKAS discussions and hope to add Ebadon and Majato schools to that international climate adaptation discussion within the young people of the Pacific. We intend to write this up for a publication themed on the whole of society approach to complex emergencies. Climate change is the most complex emergency we've ever faced, and we're pretty sure efforts like this one, interweaving everyone from National Parliament Senator to an ONR program manager, to Living Labs in Paris, to US Indo-PACOM, to Hearts in the Ice in Norway, to our very own patient families, can help show the way to a happier, safer, and more prosperous future for all of us. Thank you very much for taking the time to join me today. I recognize it's an inconvenient time for most people, but I'm very grateful that you are willing to be here. That's it. I'll stop, and please get in touch with me for questions. Thank you.